Okay, so we're recording here. It says Monday, December 2nd, so we are in the final stretch of the class, last 4 days. One thing, whoops, it didn't come through here. Hold on just a second. Supposed to be an announcement that is visible to you now. I don't know why it's not. Hold on. Let me go to a setting. So, anyways, let me tell you what I did because we are uh, here in the final stretch. Here we go. Good. Here in the final stretch of things, I wanted to start doing some sort of review um, of various things. Let's see if it came through. Okay, here it is. So if you go to the Math 88 course, there is an announcement. It's not an official assignment. I'm not going to make it, graded, if you will. But I want you to take a look at it and work on it tonight. And when you click on it, when you click on the announcement, you should see the Word document that I've loaded, final review functions, dot Word document. Now that Word document looks like this. Okay, this Word document here's what it looks like. And so it has basically using these functions answered these 7 questions down here. And that covers a variety of things. Um, the first question here on finding the vertex, remember the vertex corresponds to a quadratic function. So I'm asking about g of x, which is a quadratic. How do we know it's a quadratic? Because it has an exponent of 2 over the x. The degree of the polynomial is 2. So you want to dust off your process for finding the vertex of a quadratic function. I ask you to evaluate. You have f plus g evaluated at -2. I have f divided by g of x, so simplify the function. I have the composition function g of f of 0, so going over those different operations of functions. Some of the newer stuff, finding the zeros of G. What does it mean to find the zeros of G? Just a quick refresher. It means you want to find the x-intercepts, which is the same thing as saying set it equal to 0 and solve the equation. Oh, that's a quadratic equation all the way back from a month ago now, 6 weeks ago. Either you can do factoring, you can do the square root property and this one, or you could do the quadratic formula. So there's a couple different avenues. Find the y-intercept of f. What does finding the y-intercept mean? What do I have to do? Remember, the y-intercept is when x is 0. So plug in 0 for x and then evaluate to find that. And then also, hey, which one of these functions, f or g, has an inverse? One of them does, the other one doesn't. And so then find the inverse of the function that does have an inverse. Addie, you have a question? Let me see. Oh no, y'all are just typing. It looks like. Okay.
Um, I have,
Yeah, go
I
ahead,
s- I
Jan.
have a s- okay. I'm like getting really frustrated. I literally have not been able to do anything because my computer broke. I couldn't see, I couldn't hear. I just got a new computer. I literally just got everything set up. It wouldn't let me get on now. Let me get on. I still can't see anything that you're doing. Is there like a button I need to push? Like I can see y'all's faces. I can hear you. I cannot see what is on your
Let me.
like your board.
Can anybody else? Can everybody else see? You can see. Okay.
Yes.
Yeah, I mean, it's a brand new computer. Like I
Yeah.
literally just set everything up. I just don't know where if there's something I'm
Let me.
supposed to
Let me.
push.
Let me do this. Let me redo it. How about that?
No, I don't see
No.
anything.
Uh, I don't know. I have to admit. Let me see. Let me see. I don't see anything in the settings.
Yeah, and I don't want to hold you up, but I just
Oh,
don't know.
What kind of browser are you on?
Well,
Google Browser.
I have Windows S, But I even tried to download Firefox because it kept saying that.
Google Chrome.
Well, no, I think I am on Google. Hold on a second.
Google Chrome was what did it for me.
Like you
Yeah.
couldn't see the screen.
I couldn't do anything until I got Google Chrome on my iPad. And then when I got my new iPad the other day, I had to set the whole thing up again with
Well,
Google
this is an
Chrome.
HP. It's not
Yeah.
a. It's not an iPad.
No, I meant
Yes.
like still, even whenever I was doing those stuff and I went to the IT, they were like, yeah, no, it works better on Google Chrome. So,
Okay. Well, I think I'm on Google, but I don't know if it's Google Chrome.
yeah.
I
Try
use
downloading the
Firefox.
WebEx apps. That's what
Yeah.
helped me. Whenever I downloaded the WebEx app, I was able to see everything that he was showing to the class and hear him. Because I know me and you, Jana, had the same issue.
Yeah, but
But
I
it's
don't like
true.
this is brand new. I don't know why it's doing this.
Uh, it's true. What ends up happening is you enter WebEx, and WebEx is its own app, separate and apart from Google Chrome and all that stuff. So you want to check your WebEx settings. I think is probably where it's going.
Well, I couldn't. It wouldn't let me download WebEx. It made me join from the browser, and then it let me log on.
But it didn't open WebEx and say like join the meeting or. Uh,
Oh yeah, I hit join the meeting. I had to log in my information, but like it wouldn't let me download the app and go through the app. I just went through Canvas and I clicked WebEx and login stuff, and then it brought it up. And I don't know.
have you maybe tried from your phone?
Well, I was doing it through my phone, but it's just really, really hard to see it on your phone.
Yeah.
Um,
Let's see.
uh, I'm gonna keep messing with it, and I mean, it's being recorded. I'm gonna keep trying to see if I can figure out why it's not letting me do it. So if I download Google Chrome, it might work, maybe.
Maybe so. Yeah, I agree. Worth a shot. I don't know.
All right, I'm gonna give it a try. I don't want to hold y'all up anymore.
That's fine.
Alrighty, thanks.
So just this is a quick recap. I mean, I kind of just looked at the homework and I said, "Oh, that's a good question." Just kind of picked a few things. So this is definitely some sort of stuff that you could anticipate, and this actually comes from stuff after our last test as well. So this would be good stuff to review, practice. I'm not making it graded. We'll go over it probably tomorrow or something like that. But I want to give you a chance to try it on your own to see it. So where are we? So by the way, just a kind of a quick refresher on that, you can find this in the Math 88 class. Math 88. Just to make sure it's in an announcement as well. It's not a graded assignment, just to give you a heads up. Now, on that note, I looked in the grade book for has everyone submitted the skill reviews, and there's many of you all that have not, or there's like one the last skill review, many of you will have not submitted that last one. So make sure that you go into the skill reviews and submit those. Just kind of a quick heads up here, which is the one that most people are missing is. Oh, hold on, it's this one down here. This is the one that many students are missing. So just to give you a heads up there. Make sure that and so just a quick recap. Make sure you submit all the skill reviews. You are getting a grade for this for the Math 88 part of it as well. It's based upon the skill reviews. So if you're missing a skill review, it's gonna I have to put a 0 in for it. It's gonna drop you down. So check your grade in there too. Make sure you're if you're missing anything or whatnot. Okay, so let's go here. Let's pick up where we were at. And oh, by the way, I'm kind of a little flighty, but I hope you had a good Thanksgiving. Uh, I know we had a little bit of a break there. We didn't have our WebEx on Thursday because of Thanksgiving, so I hope you had a good, restful weekend, long weekend. And so just to kind of, what do
I
we?
have a quick question.
Uh-huh.
When exactly does all these assignments have to be due by? Like done?
Right there, December.
It has to be by December 8th. Okay.
Yeah, that's. I couldn't hear. Say it again. Try it again. As it was cutting out.
do the semester end on December the 8th?
No, so December 9th starts finals week. Starts finals week. So, I mean, let me say it this way. Maybe I'm misstating it. Let's see. December 12th, I think, is the last day to submit everything. December 12th. And that's when the final exam is going to be due by as well. And I can't go beyond that because I have to submit grades, and it'll be my first time doing it, so it's going to take me a while. But anywho, this gives you a few extra days to get everything in order. If you're missing one or two homework assignments by the end of it, don't stress yourself out. It's just one or two. It's not going to make or break anything. But you want to have the bulk of it. So anywho, you'll probably see the final exam appear here pretty soon. I think I'll probably do it tonight. Formally created. I have to say I I took the weekend off from everything, so that's why you don't see it yet. Okay, so let's pick up here with some of this final stuff, and some of it you've already have exposure to, and you're just going to add a new skill, one or two new skills. Some of it's going to be brand spanking new. So let's take a look at the rational functions and inequalities, and then probably shoot down here to power rules for exponents and rational exponents. And maybe I'll actually go in that reverse order, do 6.2, 6.3, and then go back up to 5.5 because they kind of go together, if you will. So I'm going to do the power rule right quick. And again, this is probably stuff that I think we did the power rule back ages ago. It feels like ages at least. So, but anyways, this will be a good refresher for that section of material as well. Okay, so what is the power rule, by the way? Remember we had the different properties of exponents. We had the product rule, the quotient rule. Then we had the negative exponent rule. And then we had the power rule. So we went over all those. The product rule is when you're multiplying the same base, you add the exponents. The quotient rule is when you're dividing, you have a fraction, same base in the top and bottom of a fraction, you subtract the exponents. Negative exponent rule says if you have a negative exponent, move it across the fraction bar. And the power rule says if you have a power of a power, multiply the exponents. So in this one here, that's exactly what we have, is we have a power of a power. So we just multiply the two exponents and we get what? Y to the 3 times 4. Oops. 3 times 4. And then that's going to give us what? Y to the 12th. That's it. Is that familiar to you? That rule that we did about, I guess, probably 2 months ago now? Okay. I'm assuming so. Let me know if not. I do want to fill in where I need to. Okay. So again, more exponents. But here, let me throw this one to you all. This is a good review question. How would you do this one? This goes all the way back to the very first week of class when we talk about the order of operations. How do we do this one?
If you multiply a negative any like odd number of times, does it always come out negative still?
True. Yes.
I guess where I get tripped up is like when it's not in parentheses. I know.
Right.
That's
that's the key here. It actually doesn't matter in this particular one. So
right.
But how does this one work? Well, this one says, what's being raised to the third power?
-3 or 3? That's where I get confused.
So when the 3 is on the outside of the parentheses, everything, both the negative and the 3, are grouped together and being raised to the third power. But here, the 3, the negative is not grouped with it. It looks like it is. So my point is, in kind of reflecting back, keep in mind that a negative is the same thing as saying -1 times 3. That's what a negative really is. It's -1 times the positive value of 3. And so when we have negative 3 to the third, just the 3 is raised to the third power. So we do that expansion, 3 times 3 times 3, and so it gives us negative 27. Now it ends up being the same thing as negative grouped together, 3 raised to the third power. So it ends up working out either way in this case. It's not a big deal. But the point is, and this is a good review because it's going to be on your final, is when the negative is not grouped with it, the exponent only applies to the number that's right over, not the negative. And that's in contrast to this one. If we had negative 3 grouped together, then what's being raised to the third power is the entire thing, negative 3. Now, it's still the same thing, fortunately for us. Okay, that's a good review. You're going to see that. All right, remember what the zero exponent says. What does the zero exponent rule say? Anybody remember that one? Yeah. So whatever's raised to the 0 power is going to be is going to simplify down to 1. So what is being raised to the 0 power here?
8xy squared.
Everything inside. So that's going to convert to a what?
1.
That's going to convert to 1, and you just bring down the negative 4 on the outside. And so this gives us the final answer of?
Negative 4.
Negative 4. So this is what I was suggesting earlier, is that this particular lesson, 6.R.2, is not new stuff. It's actually a refresher of old stuff. Here's another good one on the properties of exponents and looking at it. So what do we got going on here is we got 3m to the third n to the negative 2 n cubed, all of that raised to the third power. And you have to sort of remember what your rules of exponents are. Product rule, quotient rule, negative exponent rule, and power rule. So let me throw this one down to you. What would be your instinct? What rules, and you can apply these rules in different orders. Maybe Addie wants to apply the quotient rule, and maybe Isis wants to apply the negative exponent rule. And you both would be right. I'm not saying there's one way to do this. So let me throw it to you. What's your what's sort of the, not instinct, but kind of what do you want to do? What rule do you want to apply? And the reward for answering is going to be to do it. So it's a joke. So okay, hold on. I think my internet's pretty weak. Bear with me a second. I'm gonna move. Oh no, okay. I have to do this. No, I have to do this. Hold on. Okay, it's fine. Internet's weak up there. Why don't you switch it in? That's a good idea. Hey, dude, let me take your room and go somewhere else.
If you want to use my office.
It's okay. Come on, Fred.
Oh.
I know. Thank you. Okay. All right, so I had to switch rooms. Sorry about that. The other office was a little too far away from my Wi-Fi. Okay. So I've probably given you enough time now. What rule? Product rule, quotient rule, negative exponent rule, or power rule? Which one do you want to apply first?
I do want to do the quotient. Like I would do the quotient rule first.
I don't mind the quotient. So what are we
I
going to
guess
apply the quotient rule
I'm
to?
thinking 10,000. What's that? To everything. Is it everything on the top or everything in the parentheses? I tend to get confused with too.
So what does the quotient rule say? When you have the same base, when you're dividing the same base, you subtract the
Oh,
exponents.
okay. I'm just thinking about I'm not, maybe maybe I said the wrong rule, but what I want to do first, my
Mhm.
first instinct was to be to apply the exponent of 3 to everything in parentheses. So what would that be?
Well, you
Oh,
could do you
that's sorry,
could do
that's
that. You could do that. I would probably recommend against that, if only because remember in the
okay.
remember in the order of operations, you work inside out. So
Okay.
let's work inside out first.
Okay. I was thinking parentheses, like PEMDAS, so that's why I guess I was wanting to do
No,
that.
but that's right. But even in that, even in PEMDAS, you go
Within the
inside.
parentheses?
So what I would do on this one is
Oh,
I would in some way you have to work with the ends. The key here is the n. You have an n in the top and an n in the bottom, and you need to resolve those. You
okay.
could do the negative exponent rule, or you could do the quotient rule. It doesn't matter. I'm going to do the negative exponent rule first. And what that says is I take this n squared, that's the one with the negative exponent, and it shoots down to the denominator. Shoots down to the denominator. Okay? So that gives us then what? 3m to the third. Now what's in the denominator? That n to the third that was originally there, and then n squared. All of that to the third. So this was the thing here that we moved, and that's the only thing that moved because it's the only thing that had a negative exponent.
Once it's
Now,
moved down to the bottom, do you add them?
now that the n cubed and the n to the second are multiplying each other, that's the product rule. When you multiply the same base, you add the exponents. So we can simplify then. So the numerator stays the exact same, the 3m to the third. Now the n squared into the third at the bottom becomes n to the fifth because we add those exponents. And now we can't do anything else inside the parentheses. The m and the n are different bases, so we can't simplify those. So now we would apply the exponent of 3 on the outside. And so when we do that, remember, everything gets its own exponent of 3. So 3 to the third, m to the third to the third, and then what? N to the fifth to the third. Everything got its own exponent of 3, and so then that gives us the final answer. 3 to the third is 27. M to the third, you multiply the 3's here. 3 times 3 is 9. So that gives us m to the ninth. And then n to the fifth to the third, you multiply the 5 and the 3 to get 15. And that's the answer. That's the answer. 27 n to the 9th, n to the over n to the 15th. Questions on that one? And by the way, Addie, if you would applied the exponent of the 3 first, you would have gotten the same thing. So don't let me deter you. Don't let me discourage you from doing that. Try it out. Play around. You would get the same thing. It just may be a little more work or confusing along the way. That's my point.
Yeah, I'd like to avoid confusion. I appreciate you not knowing.
Anybody have any questions on this one? All right. So far, it's just review. It's just review on the rules of exponents. Again, I'm not going to belabor this one now. This one I think we had. I don't think I really did it. When you have the negative exponent on the outside of a set of parentheses, how does that one work? How does that work? Does anybody remember? Everything is being raised to the negative 2 power. So everything is going to shift. The 4 is going to shift from the top to the bottom, x from the bottom to the top, same thing as y. So essentially what that means, When the negative exponent is on the outside of the set of parentheses, it means that the fraction on the inside just flips over. Everything flips over. So if we apply the negative exponent first, the x, y to the third shifts to the top, the 4 shifts to the bottom, and that exponent of -2 out there becomes a +2. So the negative part of that exponent out there causes the entire fraction to flip over and turn in, so you turn the, and now you just raise everything to the second power. So this becomes x squared y to the 6th power over 4 squared, which is 16. Okay, let's see what else. I don't know if there's really anything new. I mean, rules of exponents, okay, more on that one. So that's pretty much it. More, they're just like, they're doing more negative exponents and more power rule than anything. Okay. Yeah, so it was all really the same. Okay, any questions on any of this so far? So let's go back home and let me go to the other one. Rational, now I want to do rational exponents. And notice it says rational exponents. Just a quick preview, rational means fraction, so rational exponents means fractions as exponents. Fractions as exponents. We haven't seen this before. But even though we haven't seen it before, you actually know how to do it because we've actually been working with fractional exponents. You just didn't realize you were working with fractional exponents. So let's see what we got. Okay, so I'm not going to do this one yet. Let's see. Oh, I see. So let's start off with something. Notice what we have here is we have the cube root of x to the 4th times the cube root of x to the 5th. Do y'all see that? It's the cube root. The little 3 sitting on the ledge tells us it's the cube root. Now, before I dive into this, let's talk about what are we going to do? What do they want us to do? They want us to convert this thing to some expression with a fractional exponent. Okay? Meaning that we're going to have an exponent that has a fraction, a top and bottom. Okay? So the question is how do we get a fractional exponent from this thing? Well, there's a rule, and so here's the rule. Okay? So here's the setup. The m root of x to the n becomes x to the n over m power. In other words, the root of the radical becomes the denominator in the fractional exponent. The root of the radical becomes the denominator in the fractional exponent. So when we do something like this one over here, the cube root of x to the 4th, you take your x to the 4th and make it a fraction where the denominator is that root. So this becomes x to the 4/3 power. The root of the radical becomes the denominator of the fractional exponent. With that in mind, how would I convert the other one, the cube root of x to the 5th? How does that written as a fractional exponent?
It would be x with 5 over 3.
X to the 5/3 power, right? So, okay, let me pause there. Any questions on the process for converting? The root of the radical becomes the denominator of the fractional exponent. Okay, so let's approach this question then. Let's approach this question. So how would we do it? What they want is they want you to write it as an exponent using exponential notation, which means write it as a fraction, which means write it as an exponent. Don't write it as a radical, convert it to exponents. So we've seen these. This becomes x to the 4/3, and then the second one becomes x to the 5/3. And that's what we just did a minute ago. Now, how can we simplify this thing? What rule would we apply here? X to the 4/3 times x to the 5/3.
Exponent rule?
What do you have in mind? What do you want to do? Look at
Not
what
really
we got.
sure.
Look at what we got. What do we have? Are we
You have the same denominator for both of them, so I'm assuming we can do something with that.
maybe so? Don't focus on the exponents yet. Focus on the base. What's the base in each?
They're both the same. They're both x.
X, they're both x. They're multiplying each other. So we're taking the same base and we're multiplying it. What do we do with the exponents in that set?
You add them.
When you have the same exponent, when you have the same base that's multiplied, you add the exponents. So we end up adding the 4/3 and the 5/3. And that's going to get us what? 9/3, x to the 9/3 power. And that simplifies to what?
3.
X to the 3rd. So my point is even with fractional exponents, your other rules still apply. Product rule, quotient rule, negative exponent rule, all those rules still apply. Even with fractional exponents. So we're going to do another one. Don't you worry about that. Because fractional exponents are odd. So let's do this one. Well, this one we already know. That's x to the 4/3 power. What does this one convert to? The cube root of x squared.
It's going to be x with 2/3.
Right. We're multiplying the same base of x. So we take our two exponents and we add them together. So this gives us x to the 4/3 plus 2/3 power, giving us x to the 6/3, and this fraction 6/3 and the exponent happens to just simplify down to x squared. Cool beans?
Cool beans.
No, it's not too terrible. It's just weird looking. You know, fractional exponents and all that stuff. It's just odd. Okay, so how would we do this one? So the 6th root of 3 to the 5th. How would we write this using exponential notation? How would we write this using exponents?
So it would be 3 with 5/6.
Yep. And there it is. That's it. There's nothing else we can do.
There's nothing to do.
Nothing to do.
It just wants you to convert it.
They just want you to convert it. When they say exponential notation, they're meaning write it as an exponent. Write the same thing with an exponent instead of a radical. Feels like there should be more, huh? But there's
Yeah, it
not.
does.
I mean, I'm happy. We don't have to do anything else,
I
but
should be able to breeze through this afternoon after this class, but like I'm gonna miss something.
Let's see what
yeah,
else
we're
they
a
got.
little nervous.
Okay, now this one says they want you to go in the other direction. Take the exponential expression. When they say exponential, they mean the expression with an exponent, and write it as something with radical notation. So how do we do that?
So you flip it backwards, right?
We told you, look, we told you that the m root of x to the n converts to, a fractional exponent. It also goes in the other direction too. The denominator of the fractional exponent becomes the root of the radical. The root of the radical. So, in other words, x to the n over m becomes the m root of x to the n. It works
So,
both ways.
so it's
So, in this expression here, before we go forward, what is being raised to the 3/10 power?
the 9y.
The y for sure, but what about the 9?
I would have just put the 9, to be honest with you. I would have put 9y, and then I'd have rearranged it how it was
Remember,
before.
there's nothing jamming the 9 with the y together. Even though they're written next to each other and they look like they're paired together, there's no grouping symbol. There's no parentheses jamming them together. They're not married. They're just happen to be sitting next to each other in a movie theater. Okay? So it doesn't mean they're married to each other. It's the grouping symbol that actually pairs them together. Okay? Where the
Right.
9 goes, the y would follow. But we don't have that here. So when you don't have that, the 3/10 exponent just applies to the y, not the 9. So think of it this way. This is the same thing as writing 9y, 9 times y to the 3/10 power. Convert that. So the 9 hangs out in front. And this becomes the 10th root. Take the denominator, it becomes the root of the radical, y to the third. And so now we can drop that multiplication symbol now. Well, and so we get 9 10th root of y to the third. So it's the grouping symbol that's important. That lets you know if something is or is not. Excuse me. Okay. Do another one. Okay, 3z to the 5/6 power. 3z to the 5/6 power. What do we get on this one?
9. So sorry, you have 3 to the 6th power, and then in it you have the z to the 5th power. You have 3.
Oh,
Sorry, you have 3 by itself, and then you have um yeah, 3's on the outside, right?
3's
By
on the
itself.
outside.
Okay, and then you have the 6.
And this is called a radical.
Sorry, your radical is 6. Then inside of there is z to the 5th power.
And so it's the 6th root.
Yeah,
The
6th root.
Of z to the 5th. Right.
Okay.
There you go. Without the 6th there, it'd be the square root. So it's just, anyway. Questions? Eddie, you got something? Go for it.
No, no, it's good.
Okay.
I just wish, like, part of me wishes I knew what all of this meant, but part of me is like, don't worry about it. Just remember it for the test.
It's true. I can tell you, I have never used fractional exponents, other than
I'm really happy to hear that.
the square root. The square root is the only
Yeah.
thing.
Okay, good. I'm really, really happy to hear that as an adult that I'm not gonna have to face
By the way, how would
molding
you write the square root of y as an exponent?
y squared, y the second power, right?
Well, the second power becomes the denominator. What's the numerator?
Oh, 1/2.
1/2. Yeah. When you raise something to the 1/2 power, you're taking the square root. It's the same
I
thing.
guess it's kind of confusing because whenever we would you know, we would there was a couple of lessons when we were working with radicals, and in
Hmm.
order to get rid of a radical, you want to like square both. Do you remember what I'm talking about? It's kind of hard for me to explain, but
True.
okay,
Squaring both sides, let's do just a
so you
quick
square both
refresher.
sides, get rid of it, and you
When you square both sides, that's when you have an equal sign. Okay?
right, but then you'd put an exponent of 2.
True, because you're doing the opposite. So remember, equal signs in your problem mean you want to solve
Uh-huh.
9 times out of 10. And you want to look at the direction. Solve means do the opposite. So here we're doing the so and by the way, that that is why we square, by the way, because we can write this as x to the 1/2 power. Okay? Let me change this to a 4 so I don't get confused. I can change the square root to 1/2 power. And there was question, why is the square the opposite of the square root? As well, because I want to turn this thing into 1. I'm going to apply the power rule. So what do I have to multiply 1/2 by to turn it into 1?
Another half.
So that's adding. Remember what I have to
Right.
multiply.
Got you, yeah.
That's why I square, is because when I apply the power rule to this, 1/2 times 2 gives me x to the first power, which is just plain old x. So it would have actually been more helpful to have done, to have done the fractional exponent way back then, because we could actually see a little more clearly. This is why square root and square are opposites of each other, is because of this notion of the fractional exponent meets the power rule.
Oh, thank you.
Sure. Let's see. Press forward. What do we got? Oh my God. This is
Ah,
just ridiculous.
hmm.
Okay, wow. Well, you got to just, let's say, simplify the following expression using rational exponents. Leave your answer in exponential notation. So they don't want you to convert. They don't want you to convert to radicals. They want you to keep it as fractional exponents. This is a mess. This is ridiculous. Okay. So let's do something. I'm not going to do all of it, but I'll give you the flavor. So let's do this one right here. So notice the 1/3 exponent is sitting on the outside of a set of parentheses. So that means you have to take everything and raise it to the 1/3 power. So the 64 is raised to the 1/3 power. The x inside raised to the 1/3 power. And then the y to the 1/6 also raised to the 1/3 power. So this top one becomes 64 to the 1/3, x to the 1/3, y to the 1/6 to the 1/3. Good so far? All I did was just say, hey, everything inside is getting its own 1/3 power. Cool? Because now what do? Well, we simplify as best we can. This thing here we can simplify. 64 to the 1/3 power. How does that convert into a radical? It becomes the cube root of 64 to the first power. Well, that's just 64 then. So what's the cube root of 64? Four. If you ever had a question, do it on your calculator. This thing here, nothing can happen to it. So bring it on down. This thing here, how are we going to simplify this part of it? Exponent of an exponent, that's the power rule. And the power rule says you do what to the exponents?
Multiply.
So 1/6 times 1/3. And that gives us what? Y to the 1/18.
Okay.
That's just this component right here that I got circled in red. You got to do that for the other parts too. The same exact thing. So let's remember this one because we'll come back to it. Okay? Now,
Okay.
let's do the bottom one. Because what are you supposed to do once you simplify all this? So do it again. So now we're going to focus on this one. Give everything, you have a 1/2 exponent on the outside of the parentheses. So everything inside gets its own exponent of 1/2. So this is 49 to the 1/2, x to the negative 1/2 to the 1/2, and then y to the 1/2. Simplify where you can. What is 49 to the 1/2 power? That's the same thing as saying what? Square root of 49, which is 7. This thing here, power of a power, multiply the exponents. So it's x to the negative 1/2 times positive 1/2 gives us x to the negative 1/4. And then y to the 1/2, nothing can be done to it, so just bring it on down. That's what this thing is, right there. 7x to the negative 1/4, y to the 1/2. Okay, so we've simplified. So what we've done here, let me kind of reset. We took this first fraction here, and we applied the outer exponent. And what did we get? Just a kind of a quick recap. We got 4x to the 1/3.
Y to the 1/18th.
Y to the, 1/18th, thank you.
And then
All
under
of
it,
that
you
over 7 x to the negative 1/4, and then y what? Y to the 1/2. Can I apply any properties to simplify this thing? The answer is yes. I have the same base on different sides of the fraction bar. What rule could I apply there?
Subtract
The quotient.
1/18 or subtract 1/2 by 1/18. Or in the
Other way. So remember, it's top exponent minus bottom exponent. So
okay, so here's my question. Do you want to address the x to the negative 1/4 first?
yeah, actually,
Or can
we
you
could.
just go
How
ahead
could we
and
address that
subtract?
first?
You bring it up, you bring it above the fraction line, the other side of the fraction line, and make it positive.
Yeah, that's a good point. I actually like that way better. I meant to do that.
So I guess the other way would be, and would you come up with come out with the same answer if you subtract -1/4 from 1/3
You could.
with the x.
Remember, it's 1/3 minus -1/4. So it would become 1/3 plus 1/4. So here we would actually add these two because we brought it up. And then what about the y's? 1/18 minus 1/2. So now you got to use the rules for adding and subtracting fractions. And you need what? Common denominators.
Right.
So this is x to the 7/12. And then funny enough, this one here, oops, hold on, sorry. This is y, 1/18 minus 1/2 is 1/18 minus 9/18, which is y to the -8/9. And we then can take this thing and shift it down to the bottom. So it becomes y to the -8/9, but shift it down to the denominator to give us y to the +8/9. That's what this thing, this first fraction reduces down to. Is that.
I have another question. I'm kind of stuck on that and intrigued by the negative exponents and like what to do with them. So for this one, we first brought the x to the -1/4 up, and we simply added 1/3 and 1/4.
Right.
But I'm kind of confused because in a previous problem we had now I'm looking for it. Oh, it was n to the -2 power of -2 over n to the third power.
Mm-hmm.
And we brought the 2 down and we oh, just kidding. Never mind.
Yeah, added.
It's the same thing. Yeah.
Yeah, same thing.
Ignore me.
Ends up being, yeah, no,
Yeah.
that's good. It's just kind of in a different location.
Yeah.
Okay, this is an exhausting problem, but the point is, and hopefully what you see is, it doesn't use anything more than what you already know. It's just it's putting it on steroids. It is a complex problem. So you take the outer exponent, give everything its own exponent of 1/3, its own exponent of 1/2, simplify them using the power rule, and then take the quotient rule or the negative exponent rule and simplify the fraction itself. So this is what you get when you simplify that first fraction. Now you would rinse and repeat for this one, okay? And I'll tell you what you get for this one. Goodness. X, this is x to the 1/8 minus, oh, I can see already. I need to go down to the bottom. So let's see, this one up here is going to be, and so that's 6 x to the 1/8 minus 1/10 is 4, 5, nope, 5, 4. So this is x to the 1/10. I'm running out of room, sorry. So this one here, 6 x to the 1/40th y the 1/2 in the bottom. Okay. So this is what you get when you do the second fraction, this thing here. Now you take these two and you multiply them with each other. change my color ink. It's not doing well. Can't really see it. I hate to use red, but I'm going to use red. So x. So now you multiply the two things, you get x to the 1 over 40 over 6y to the 1/2. Oh, well, I'm sorry, not 1/2, 1/4. 1/4. Made a mistake there. It's not 1/2, it's 1/4. It's just too, my pen is too thick for all this typewriting.
We were sitting here thinking that it was going to be too easy, and then look, this.
Yeah, this is a
Yeah,
zinger.
I
This
figured.
one's pretty much unfair.
Right.
I would have never asked this question, but the point of what they're trying to do is they want you to take all of your rules, fractional exponent, power rule, product rule, quotient rule, negative exponent rule. Oh, and by the way, you know how to work with fractions too. Let's throw in some fraction, all your add, subtract, multiply, divide fractions. It's exhausting. It's
I thought
exhausting.
they were just trying to give us an aneurysm, but that's fine too.
It is. It is. And so now you're going to have a mondo fraction to deal with here. You got to add those. 7/12 plus 1/40th. Ridiculous.
Oh, shoot.
So I don't know why they did that. That is a completely unfair question. Unfair.
I gave up.
I don't know about it's unfair. It's one of those things of I would give up, and it's obscene, and
Well, it's
I've got some emotions with it. It's not it's detracting from the core of what we need you to do. Do you know how to
yeah,
work with fractional exponents? I would have been satisfied with just one of these.
yeah.
Just giving you one of the fractions. I don't know if you.
It's
I don't know
fine for
why they
like a
have to do the whole
bonus
thing.
problem.
So
Just something
it's
extra, but
nuts.
it's okay.
So I apologize for that. Okay. So negative 10,000 raised to the negative 1/4 exponent. The negative matters. The minus in front. That is not being raised to the negative 1/4 power. Not. Okay? So you would treat this as negative 1 times 10,000 to the negative 1/4 exponent. Because the negative is not grouped with the 1,000. 10,000, I mean. Now I'm going to come down here. The negative 1/4 exponent, you apply the negative exponent rule, and this becomes negative 1 over 10,000 to the 1/4 exponent. Now you convert the exponent of 1/4 to the 4th root of 10,000. And if you did that on your calculator, what would you get? 1/10. The 4th root of 10,000 is 10. Do you have to know that? No. Calculator.
So it's 1
Oh,
over
sorry. Negative 1.
4th.
I forgot my negative.
Oh no, but still, I'm still having kind of the same question. So it's 1 over the 4th root of 10,000.
Because this thing is the one that's being raised to the negative 1/4. So it's the one that shifts across the fraction bar. Only that part.
Gotcha.
Okay, so it's just more of the same now. Negative exponents, power rule, all that jazz. All right, so what I'm going to do is we'll leave it here. Start working on that final exam review. We did what we need to do. I have a meeting, I have a thing. So do that final exam review just to kind of quick recap where it's at. It's in the Math 88 form in the announcements. in the announcements, and you can download it from there. Try it out. It's not graded, but try it out. We're going to do it when we meet together tomorrow. I'll give you the answers and show you how it's supposed to work. But this is a good, this skill review is a good one to test your skills on functions.
Yeah.
All right. We'll catch up with each other tomorrow, and I'll post this video a little later tonight for you so that you have that.
Awesome. Thank you.
Yeah, Isis, you have a question real quick?
Oh no, I was saying see you later.
Okay, yeah, that's what I thought too. It looked like there was a hand wave. All right, folks. Hope you have a good one.
Okay, see you later, Professor.
All right, bye-bye.